Hey everybody, here's our CS302 assignment 8, which is going to, I guess, be a smart stock brokerage account or a smart stock market system slash program. So this program is designed where you'll have a set of stocks, and each day you're going to have a price of a stock, and you're going to basically always buy one stock at a time, and you're going to use a priority queue to always pick the next best stock to purchase. So I guess this first paragraph here just sort of goes over, I guess, a little backstory to this. So yeah, Elon Musk, yeah, he is a smart man, rich, invest. Of course, stock market is kind of a dangerous place to invest. Well, not too dangerous depending on how you play it. Of course, never invest in the cryptocurrency unless you really feel lucky. You can go ahead and go for that. So, it's supposed to be a typo. It can be a challenge, not any, but get the idea. So anyway, so basically, you're going to have a list of stocks. So we're going to use this struct stock type designed right here. So every stock will have a name, amount of times purchased, a dividend percentage, and a price of a stock, and along with its comparison. So I believe in our input files, we're going to have 25 different stocks we're going to basically use. So we're going to have a vector or maybe even unordered map of stock types. So we have to maintain all of our stocks, maintain their prices, update them, and of course, using a priority queue, always pick our next best stock. So you're wondering what does this portion right here supposed to be? Bool operator question mark. So you're not going to actually overload the question mark operator. That would be pretty cool if that were the case, but you're going to overload, less than or greater than or something like that, because we're going to be using a templated priority queue class, and we don't want to be too specific. So you want to go ahead and arrange our stocks that we have available according to some kind of priority. So this is going to be the priority you want to implement for stocks. So basically, the stock with the cheapest price has a higher priority. And of course, if let's say you have multiple stocks with the same price, then we're going to use the which one was purchased more as a higher priority. If let's say the stock price is the same and the purchase amount is the same, then or purchase number of times is the same, then we're going to say the one with the bigger dividend is going to be a higher priority. If all of these three are tied, then of course we just use the alphabetical order of a stock. So the idea is that this is going to be the priority we want to implement. So for the most part, for our examples, I don't think there'll be a case where there'll be multiple stocks at the same price, but I just have this here just to be really, really super safe, since I didn't verify every aspect of the input files, since they were pretty large input files I used in this program. So you want to make it so essentially what you want to have is a stock with the smallest price is going to be at the root of your binary min or max heap. So basically you want to have this operator overloaded such that when you insert into your priority queue, you're able to arrange it where, the stock with the cheapest price will be at the root, or if let's say you have multiple stocks for the same price, then the stock with the most amount of times purchased is at the root, and so forth. So you want to make sure you overload this priority. And you have to use the operator to actually achieve that. So let's go ahead now and talk about the priority queue class. And there it is, priority queue. Pretty clever play on words there, because the letter Q actually the same sound as the actual word. Q, like Q-U-E-U-E, I guess. It's like the way you spell the word Q. So it's a fun play on words. Okay, let's go ahead and just continue with this. So basically, we're going to have, oops, I was supposed to, it's a typo there. I use actually size T for these, but I decided to switch it to int at the very end because I didn't really want to go into all that. So I guess I'm going to fix this up. When you have the actual PDF up, it will have int, not int underscore T, but just let you know, I used size T originally, not int. And I didn't want to really explain what size T is, so I just switched it to int, so it's my mistake. But capacity and size are going to be both integer types, is the idea. So, as always, capacity is going to be the amount of elements heap array can store, and size is going to be how many elements are actually in the heap, same as we've done for our class lectures when we've done anything involving a min or a max heap. So, Our first constructor, it's going to use a default argument. So we go to the definitions right there. We have int cap. Well, if you don't pass anything into this constructor, cap will take the automatic value of 10. And we're going to assign this value cap to capacity, allocate the heap array, and set the size to 0, I guess, is the idea. So that's all we're going to be doing for the first constructor. Now, this constructor right here, so I'll probably go back up actually. So this constructor right here, it's kind of hard to see it with the dark theme, but this, I'm going to highlight it right there. This constructor right here is going to be the case where, oh, sorry, no, this constructor, my mistake. This constructor right here is going to be the case where you're passing in a vector of whatever type. So we can assume that the type is really going to be stock type is going to be our type. So this priority queue is going to be a queue of stock types basically. So we're making it templated just because, you know, just to create a templated type, I guess. But the idea is that it's going to be really a stock type, but we're making this a generic priority queue. So you're going to pass in a vector of types, and this one is going to overload that build heap type work. Now, you don't really have to use this in your main, but I did just to make my program a little bit faster. But the idea is that you pass the entire vector into this constructor. So you can get the size of the vector by calling the dot size function. You can set the capacity and size with whatever size this is, and then just simply copy everything over from this vector into heap array. Now, of course, I use always index 1 as my first element in my heap as a root, so it's easier to do all the math. This is going to be, of course, index 0 with the first element, so you have to kind of shift them over by 1. Then, of course, remember you call build heap from the leaves upward. So that's all you have to do for this constructor. This will be our copy constructor. We only have a single array, so I'm not going to even discuss that. We have a destructor. All we have is this array. So honestly, this cannot be anything too bad. Then you have an assignment operator. Again, you only have a pointer, just a regular one-dimensional array, a one-dimensional dynamic array, so I can't imagine any problems with these. Of course, you're not going to have to really use them specifically, but I guess it's still good sort of practice to implement these if you have pointers in our class. Now, insert function, well, that's the same idea, same sort of work insert does as we did in class. We have some type of type. We're going to assign this to the heap array at index size, and then increment size by 1, or whatever order you want to do it. So you can be consistent to what I did in class in the lecture videos. For whenever I do insert, same idea. You just insert to the end of your heap, and you bubble up from the last. So let's say you insert element into, let's say you increment size by 1 first, and assign type into size index. Then you bubble up from size. So you know the same exact work. So insert is not going to be a big problem. Now, I say delete priority because I'm not going to give away whether this has to be a min or max heap. So I say delete priority. Well, if you make it a min heap, then of course this would be really delete, you know, min value. But you want to make sure you don't modify the function names. But the idea is that the priority could be, I mean, it's up to you how you set it up. So it could be a min or max heap. It's not really important. So I'm letting you kind of, you know, mess with that. It depends on what operator you overload for this stock type class is the idea. So insert to the back of the heap, bubble up. Delete priority, remember you take the last element in a heap, overwrite the root with it, and then you bubble down. Decrement size by 1. So same as I did in class, not much to explain there. Of course, you can watch those videos on heap sort or heap lectures as well on my YouTube channel if, you know, you have to refresh this, but same concept, nothing really different there. Type get priority, so you want to get that, you know, get that root element. So this returns, remember, returns heap array index 1. Is empty, returns true if the heap is empty, false if it's not empty. So that size value, if size is 0, obviously your heap is empty. If size is larger than 0, then it's not empty. So nothing too shocking there. Get size returns how many elements you have in your heap. And of course, only hard functions you have to write will be bubble up and bubble down. So bubble up, remember, when you bubble up from a certain index, this function could be recursive or it could be using a loop. And constantly you pass in some index, so you want to bubble up from this index you're passing into the function. And what you want to do is compare with the parent and then swap if the parent and child sort of violate this min or max heap property. You keep doing this until eventually you hit the root, or until the parent is, smaller or bigger, depending on whether you have a min or max heap. Bubble down, I think, is the hardest function from this priority queue class. Now, it's not a hard function, it's the hardest of all the functions in this class. So basically, remember, you have to compare the two children, whichever two children, out of the two children, the small. So if you're doing a min heap, then you take the smaller of the two children, compare that to the parent, and then if it's less than the parent, then you bubble down with that smaller child, and you keep moving that index until you hit that root elements, or sorry, that leaf element. So I guess same idea like in class. Again, it's nothing really too much to say about it. I don't want to overkill this video too much, so that's all there is to it. So it's because there's several cases you have to worry about, because you could have two children, you could have one child who could be a leaf node, and if you have two children, you have to find which child is the higher priority value to be compared to the parent, and so forth. So there's a few cases you have to worry about here, but of course, it's not too bad. Just it's harder than the rest of the functions in this class. So the only rule is, I guess I wrote it over here at the very bottom. You don't want to actually say, like right over here, I'm going to highlight this, heap array x dot price. You don't want to look at that, because you want to make this priority queue class to be specific, or sorry, not specific to any particular type. So the whole point of overloading that less than operator is so we can compare which stock, is smaller, which stock has the higher priority, so we know which one to bubble up and bubble down with, and so forth. So it's up to you. You can overload less than and even greater than, or whatever you want to overload. There's no rule for what you can or can't overload for this, but just you have to make sure you overload the operators and use that in the heap or in a priority queue. Don't actually look at the actual price. I mean, it'll work it's gonna cause no errors because we're going to be using stock type, but you want to make it where this priority queue, in theory, would be able to work with any data type, whether it's integer, double, string, and any custom type, as long as those comparison operators have been overloaded. So honestly, I hope I didn't go through this too fast, but there's not a whole lot to really say about the priority queue. So okay, so I guess now I'm going to go over the main part and also give you an idea of how to parse a CSV file. So that's going to be coming up next. All right, so I could go ahead and sort of read this for you in this video, but I think we all know how to read, or at least I can kind of read more or less. Hopefully I spelled comma correct. I think that's 2 M's as opposed to this. That's the right spelling of comma. So just to make this program a little bit more challenging, we're going to be using CSV files, but I promise it won't be actually too bad to parse it. So you'll be given 2 CSV files. Let me go ahead and open these up. So just a warning, it's going to cause a bright light will flash because I don't know how to dark theme Microsoft Excel. So it's going to be a bright light coming up. So let's open up this file right here. And let me see, I think the bright light will come right now. There it is. I apologize for that. So anyway, this first spreadsheet file is going to just really contain sort of the 25 rows. So we have 25 stocks we're going to have, 25 stock indexes or indices, or I think it's indexes is how they refer to that. So each stock right now is going to have a name. I think these are actually valid stock names. I actually use a program to kind of generate random stock names. I think these are valid, but if they're not, then, well, it doesn't really matter because it's not the important part. We're just simulating this stock market. And then these numbers right there are going to be dividends for each stock. So you first have to read an input file from the user, and you're going to have to just sort of read these in. So I'm going to go over the details as to how to read these in a little bit. I'll probably do it towards the end of the video. I want to go into the actual main contents. But for one, you're going to basically either use an unordered map or a vector of stock type, and you're going to store this name with this dividend. And of course, the price will be 0 for right now. and the amount of times purchased will also be 0 for right now. So you have to read in 25 lines, or it won't always be 25. So I mean, I guess it will be for our assignment, but you want to make sure that your program is written in a way where it can handle if you have more than 25. But the idea is you're going to have, n number of lines. Each line has a, 2 columns, which is a name, followed by the dividend amount. So you have to parse and read that in. So I think the idea of that is not so hard. I'll go over how to parse a CSV file in a second, but for now, I think the concept is, not too hard to understand. So I think we're good there. So now let's go ahead. So we have to first do that. Now I'm going to go ahead and open up. I'll have several different stock exchange files. So let's go ahead and look at the classic New York Stock Exchange. I'm going to open this up. So again, another bright light flashing. So just kind of, just brace yourselves, and there it is. So in this file, we're going to have 25 columns. So basically it tells you, so it's going to be the same order as the original file. So basically, this is going to be the price of that first stock read in that other file. This will be the price of the second stock in that file, and so forth. So the order is preserved in this file. So basically, the way you want to think about this is this first row is going to be the price of each stock at the beginning of day 1. Then this is going to be the prices. These are very not realistic numbers, but they're random numbers, so I didn't really think about them. They're very not realistic. There's no way a stock goes from $40 a share to 204 end of the day. That would be insane if that ever happened. But this is just random, so we're just gonna go with it. So this second row is going to be the price of each stock at the end of the first day, at end of day 1. And then this next row is going to be the price of each stock at the beginning of day 2, and then it's going to be the price of each stock at the end of day 2, and so on and so forth. There's a lot of lines here, so plenty of simulated, kind of random number data right there. So you're going to be reading this kind of step by step. So first go ahead, and you're just going to just read in these, and then this other file we have here, which let me just make sure I get this correctly opened up. This one you're going to be reading throughout your simulations. So I'm going to go ahead and actually just sort of go back and forth between these two files right there. So the first thing you do, just in this PDF, you have to first read in your, I guess, your n number of stocks and their dividends. And then you're going to go ahead and run these steps in main. So you're going to read one line from the stock exchange file to store each stock's price at the start of a day. So you're going to first go ahead. So I'm going to I think I'm going to close this one. I'm going to keep this one open now. It's a little bit of trading back and forth. So I'm really sorry about this, back and forth like this. But you first read in one line, and you store prices. So of course, this will be the price of that first stock from that other file. So they are kind of one-to-one. So it makes it easier to parse this. So you first read in one line. And then you're going to read them in. You're going to store them into the, add them to the price of each stock. And you're going to insert all of them into a priority queue. So this could be done either just inserting all of these, or you can use that constructor to, to do that build heap operation to just make a, heap out of all that. And then this step 3 is going to be just sort of a loop will be involved here. So one by one, you're going to pop an element off of this priority queue, and you're going to buy one stock at a time. So what's going to happen is you remove a stock from the priority queue. You might want to insert it somewhere else, or some way of telling that you want to know which stocks you bought. So one by one, you have to pop a stock off of the priority queue, and then sort of add up how much total you spent. And you keep doing this until either you don't have any more funds left, or there's no more stocks left in the stock heap array. So the input, of course, I guess I should have put this here in the PDF. You also are going to read in you're reading those two CSV files. You also are going to read in how many days you want to simulate, and also you're going to read in how much money you're going to begin, how much money you're going to start with in your brokerage accounts. I guess I really rushed this PDF file. It's not really fun writing PDF files for all this. So anyway, so what you're going to do now is you basically one by one, you remove a stock one at a time, and you sort of, if you have the funds to pay for that one share, you add it to a running total. So you want to keep track of how many stocks you bought, and also you want to track which stocks you bought as well. Which this is also, this could be used as, you can have a vector of all of them, or you can use a hash map to sort of mark which stocks you've bought so far. And you do this until eventually either you have no more funds left, or you have all the stocks are already kind of bought. And then what you're going to do is you're going to read another line. So you want to compute, you want to read the prices of each stock after the end of the day, and based on which stocks you bought and how much each stock is worth from the beginning of the day and end of the day, you want to compute how much you gained. And then you can add that to your profit. And then you're going to keep on, and after that, you're going to jump back to the top and do step 1 again. If there's still more days left, let's say if you want to do 10 days, you have to do 10 of, if the run is 10 times basically, and or if you're out of funds, you also stop. Now for the input files I provided, it looks like you never run out of funds basically. So you're going to essentially stop running this program once number of days are simulated. But in each day, you basically just you pop a stock off the heap one by one, add it to your total amount of money spent, also mark which stocks you bought so far. And then once you can't remove any more stocks because you have no more funds or there's no more stocks left, you read the next line from the file to compute the stock's end of the day price, compute the gain, add it to your profit, add it to your brokerage account, the gain or loss. Then you just do the same thing, and then you go back to step 1 and do basically step 1 through 5. Just keep doing this over and over again for the amount of days read in. And at the very end, once you're done, you want to add up the dividend amount by multiplying each stock's dividend percentage with the amount of times it was bought. Because every time you buy a stock, you have to add 1 to its increment, its stock purchase amount by 1 every time you basically read a stock. Every time you pop a stock and you buy it, you have to increment that stock bought amount counter basically. So that's sort of the idea. So let's go ahead and go over the output files. So I'm going to go ahead and sort of show you over here a few of them. So here's our first output file. So in this one, so I think it's good enough. I read in stocks of CSV, New York Stock Exchange. I'm going to simulate 10 days, and I'm going to have $500 in my brokerage account initially. And then I read in, I have my 25 stocks, I have the price of all of them, and I put them into this priority queue. And notice that I first buy this stock with this much, per share. So you can see here, then it's 15, then it's 16.54. So you can see that it is sort of buying it from cheapest to more expensive. So the priority queue will help us always pick the next cheapest one. And I guess after I bought all of these, there's no more balance left. I guess probably because the next stock probably costs too much and I wouldn't have the funds for it. So I didn't really double check all my work. I kind of just wrote this and it made sense when I ran it. But of course, if I made a mistake, let me know. But I believe that what happened here was the next share was so expensive that I wouldn't have the funds to buy the next share of whatever's left on the heap array, or in the priority queue, sorry. So, and after that, all the stocks I bought with these prices, I guess I gained $434 added to my account. Now on day 2, I have this much funds, and you can see now I'm able to buy more stocks. So I'm buying 1 share of each stock. And then here's all the stocks I bought. I made this much profit, add that to my balance from day 2 and so forth. So this is just, I have three files I'll have posted on Canvas with all of this. So then this is my balance after 10 days. It's right there. And it's how much I made in dividends. Basically, dividends, I just simply take the percentage of each stock, multiply it by how many times I bought that stock, and I sum all that up. That's my dividends amount. So, I don't know, I think I went a little faster through this, but really there's not too much to say about this program. So I'll fix some of the typo. I think I forgot to add in over here, you're supposed to read in the amount of days and the and the initial brokerage amount, but I did at least go over it in this video right here, so at least, you know, it's not completely gone, but, or not completely sort of confusing, at least you have some idea. So anyway, now I'm going to go over, well, how do we actually parse a CSV file? Because that might be an issue for some of us. Maybe you didn't really cover that in 135, but it's okay. I'll definitely go over it right here for us. So I guess before I do that, I'm going to go over specifications. So of course, make sure your memory issues are taken care of by thinking this program, though, since it's using one 1D array, shouldn't be a problem. And also, yeah, make sure you use an operator, the operator for stock type. Don't just use the actual specific fields of stock type within the priority queue class, because you want to make the priority queue class a generic class. Okay, so I think I kind of went over all this. Now let's go ahead and talk about how to parse a CSV file. Okay, so let's go ahead and go over how to process a CSV file. So it might seem really scary, but really it's just a plain text file, but it's comma separated. So let me go ahead and just first, you know, for once, open up the, not for once, but just again, open up this file. So it looks like, oh, look how nicely arranged by columns this is. Look at the first line, column B, column C, and so forth. Let's look and see what actually is really contained inside of this CSV file. So I'm going to go back to folder. Let's right click, and I think it should have an edit option. Awesome. And look at that. That's, I mean, if you haven't seen this before, this is all it really is. Let's try to like, okay, get this thing out of the way. Okay, there we go. So we can see here, look, 4018, 4018, 7981, 8781. So it just separated by a comma. So the comma tells this spreadsheet program that it's a new column. So really, there's actually word or kind of line wrapped everything. See if I can split it up a little bit. There we go. So the very last sort of column was 1654 as a new line begins. The next line 204 and so forth. So really, it's just you have to parse this. So let's go ahead and go over how do we actually parse one line. Of course, you can kind of imagine how you actually write a loop to do this. Or maybe I could sort of maybe have a loop version, but I'll just kind of have it break after a few iterations, just so I don't, you know, flood my screen. So I'm going to go and sort of create a file. Actually, I already created one earlier. So let's see, where is it? There it is, CSV parse.cpp. So let's go ahead and sort of write the code for this right here. And of course, you can copy it down. So I'm going to go ahead and just include IO stream, include, I'm going to use string stream to make this work. And I guess I'll use IF stream, and I think that's about it for right now. We'll see what else I have to add. So int main, return 0, very important for code grade. I'm going to create my IF stream variable, IF stream in file. I'm going to go ahead and just kind of hard code this. So I think I have it as New York Stock Exchange.csv. Okay, like that. I guess I'll include string as well, just to be really safe. I think I might use a string function. I guess I'm also going to include cstdlib as well. So, all right, so now what we're going to do is we're going to read in one line from this file. So I'm going to go ahead and create a counter. So I'm going to use a loop. Actually, I'll first do it kind of just one line at a time. So I'm going to go ahead and use a get line, or famous, friendly, but the get lines aren't so bad. So it's only bad if you use it with the input extraction operator. But if you do that, you have to make sure you always ignore the line before you do a get line, so you flush out that line beforehand. So that's always important. So if you use that, you know, input operators always use ignore after to flush out that line to be prepared to do a new get line on a brand new fresh line. So I'm going to create a string variable. I'm going to call it line, And I'm going to go ahead and say get line in file line. Okay, let's go ahead and simply output this over here just so we can kind of see what's going on. I could use a debugger instead to do this, but I'll just, do it like this without using debugger. It takes a while to set up, or not a while, but it's, I'd rather just sort of just do it like this. The old-fashioned way, using couts as a way to debug our code. So I'm going to say CSV parse.cpp, please compile. I think it's supposed to be S. It's supposed to be just SS stream. Okay, let's see. Please compile this time. Oh, it's supposed to be just F stream. Okay, my mistake. Okay, now it's art. There we go. Now it's art. So, okay, so let's go ahead and just run this. And look at that. It read in one line. And it's all comma separated, just nice like that. Beautiful. So now we have to break apart this into pieces. So what I'm going to do right now is I'm going to get a string stream variable. So I'm going to say standard, I think it's supposed to be string stream, I believe. I'm going to say just SS for string stream. I'm going to pass in line, just like that. And while get line string stream, I'm going to create another string variable just to be safe. So string part of line. I guess that does make sense for a variable name. I'm going to say part of line. And there we go. So what this is going to do, it's going to use a get line. So on that line we just read, this is going to be in our string stream. This is going to be where we're going to be parsing. So I do a get line on this string stream until a comma is read. It's going to take this and extract it because that's going to be the characters until we hit a comma. So it's going to just simply get that. So I'm going to now just output part of line and then just output a new line like this. I'm going to comment, or we're going to remove this part. I don't need this anymore. We're convinced that the line, it does do get line correctly, so we have that. So what this is going to do basically is one by one, when I first call this get line string stream variable part of line comma, it's going to first extract this substring out. And since it's not going to return an empty string, then it's going to, like when I call this get line string stream part of line again, it's going to extract this part of the string. Then when I call this get line again, it's going to extract this part one by one. So I'm going to simply output these sort of one by one on this in the console here. Let's go ahead and just CSV parse again. And look at that. See, it's all, we were able to separate this. So far so good. We are getting there. Now, the last thing we have to do is, well, the problem is part of line is a string. I want to convert it into a decimal. Well, again, you might have already encountered this, but let's go ahead and just do that. So I'm going to now, instead of saying outputting part of line, I'm going to create a variable. I guess I'll put it up here. I'll just say double dbl num, very creative variable name. I'm going to say dbl num equals, I think it's strtod. I'm going to take part of line. I think you have to use this because it's a very old library function and requires you to pass in a C style string. So I have to use this .c_str, which will sort of return a C style string of this, a null terminated C style string. And I guess you have to put a null over here. Just I forgot the exact rule for that, but just bear with me. That's how you do that. And then of course I'll just cout dbl num, and then I'll put a new line. So we get the same output we're going to get, but the difference with this output is we're going to be outputting decimals this time, not strings in this situation. So let's go ahead and recompile this. And it still works, same output we got, but the idea was now we were able to extract them into decimals one by one. So of course now with double num, we could sort of, assign it to any decimal variable we wanted to assign to. So basically, we have to essentially wrap this in a loop. So what you'd have to do is if you want to read every single part of the line, you have to sort of wrap all this in one loop. Now I'll sort of explain what each part of this does. So this is going to read one line. This inner loop portion is going to loop through and parse that line. And then of course this is really an end of file control loop in a sense. So reading one line at a time, this will process the line. Then we get to the very top of our loop, read that line, and so forth. So if I were to run this, it would sort of parse every single line. So I don't want to really do all that, but that's sort of the how you would actually use a loop to do this. So of course you'd have a getLine function. It's going to return, if it's the end of line, returns a false, which means that it's done, it hit end of a line. If it's not a false, that means it read one line successfully, and this part's going to parse and break apart that line and convert it into numbers, I guess. So really, that's all there is to breaking up a CSV file. So I hope this video did help. I know it went a little faster through the no hashing, so priority queue. But there was not much to say about the priority queue, and the actual structure of this program is really just, straightforward. Just always use a priority queue. So the best way to think about this program, I guess, I'm kind of going back and forth here a little bit, is that you want to pick the cheapest stock every single time and then buy that. And a priority queue is just going to be used to help you quickly in log n time pick the next best stock is the idea. So I guess that's all for this video. So I hope this helped you understand everything. So I guess happy coding and till next time.